So this is the method is used to characterize the नॅनोमटेरियल्स. नॅनोमटेरियल साठी ही खूप इम्पॉर्टंट कॅरेक्टरायझेशन टेक्निक आहे सेम. सो दिस इज द कन्स्ट्रक्शन, वर्किंग अँड सॅम्पल प्रिपरेशन, ऍडव्हान्टेजेस अँड डिसएडव्हान्टेजेस ऑफ युअर nanomaterials. Nanomaterials can be a very important research field, or this is very a hot topic. So therefore, the characterization technique is very important. So this is the very important characterization techniques of your nanomaterials, that is same, right? So construction, their working of your same, their sample preparations, advantages and disadvantages of your same. The second technique, and this is a very important technique, that is the transmission electron microscopy, and the short form of this technique, it is called as a TEM. So TEM of your samples, it is give the very important informations of a nanoparticles or nanomaterials. Nanomaterials ची खूप information, important informations आपल्याला ही characterization technique देत असते. So the principle of this transmission electron microscopy is just like your the same, but here is the basic difference. आता याचा बेसिक डिफरन्स, आपण याचे डिफरन्सेस जेव्हा बघू तेव्हा तुमच्या लक्षात येईल की सेम आणि टेम मध्ये थोडासा बेसिक डिफरन्स आहे. बोथ आर द इलेक्ट्रॉन मायक्रोस्कोपी, but the scanning electron microscopy, it is a surface level, just we just observe the surface level. But transmission electron microscopy, it is in your electrons are penetrate into the samples, to penetrate hotoy, and we are using the atomic level structures also. So this is the basic difference between the same and TEM. तो आपण बघूया जेव्हा आपण याचा डिस्टिंग्विश पॉइंट बघणार आहोत त्यावेळेला. So what is the principle of this transmission electron microscopy? In this transmission electron microscopy, the electrons are allowed to transmit through the sample under the study. So this is a very important difference. इथे तुमचा इलेक्ट्रॉन काय होतोय, तुमच्या सॅम्पल मध्ये ट्रान्समिट होतो. दिस इज व्हेरी इम्पॉर्टंट वर्ड. Your sample, your electrons are transmit through the sample under the study. सेम मध्ये काय होतंय की your electrons are just scanning the surface of your material. This is your materials, and here is the pointer of your same. Just it's scanning of this one. हा फक्त याला स्कॅन करतोय. Okay, वर. This is not electrons is penetrate into the sample, but in the case of this stem, it is transmit your electrons to the sample which is under the study. Some of the incident electrons are scattered or deflected by the materials, and at the bottom of microscope, the unscattered, that is transmitted electrons, hit the fluorescent screen, and which gives the shadow image of your sample. So this is also very important word, fluorescent screen, right? So two types of the scattering is electrons over here. जेव्हा तो ट्रान्समिट होतोय, सो ट्रान्समिट होत असताना some of the electrons can be deflected by your material, nature of materials, but the electrons are, those electrons are penetrate in your sample, that is the unscattered electrons, and which is transmitted into the sample, this heat the fluorescent screen. तो फ्लोरोसंट स्क्रीन वरती हिट होते. इथं फ्लोरोसंट स्क्रीन आहे, इथे तुमचं कम्प्युटर नाहीये. सिंपल टीव्ही किंवा सिंपल कम्प्युटर डज नॉट रेकॉग्नाइज द सिग्नल्स. हियर the necessary important things is your signals can be recognized, or it can be signalized or amplified with the help of this fluorescent screen, so which is gives the shadow image of your sample. This is a very important principles of your transmission electron microscopy, right? Now the construction and working of your TEM. The major component of the TEMs are very similar to the same सारखंच आहे, फक्त basic difference, that is a fluorescent screen we are using here, and your electrons are bombarding, and electrons are interacts with the sample. It is transmitted into the sample, right? It is penetrate into the sample. Okay, so this is the two basic difference in your सेम अँड टेम. सेम आणि टेम मध्ये हेच फक्त दोन बेसिक डिफरन्स जास्त आपल्याला दिसतात. ओके, काही बेसिक डिफरन्स आहे ते आपण बघूया. So the electrons of very high energy of the order of more than 50,000 electrons volts are produced. Electrons or EVA electrons are produced in the electron gun. These are allowed to pass the through series of magnetic lenses to focus the sharply on the sample. जसे तिथं मॅग्नेटिक लेन्सेस होते तसे इथे सुद्धा मॅग्नेटिक लेन्सेस आहे. जे काही इलेक्ट्रॉन गन मधून इलेक्ट्रॉन्स बीम बाहेर पडतात ते तुम्हाला मेंटेन करतात magnetic lenses, and it is focused onto the sharply on a sample. Okay, so this is the same working of your or construction and working of your same. TEM requires a very thin sample because the electron should transmit through it. तर टेन मध्ये आपल्याला थिन सॅम्पल पाहिजे, कारण तुम्हाला टेम चे जे इलेक्ट्रॉन्स आहेत त्या इलेक्ट्रॉन्स त्यामध्ये बंबार्ड व्हायला पाहिजे किंवा पेनिट्रेट व्हायला पाहिजे, ट्रान्समिट व्हायला पाहिजे. देअरफॉर we need a very thin sample, right? Second one, this is the tuning electrons, the tunneling electron microscope or transmission electron microscopes, that is a TEM, which is firstly observed in 1932 by the German physicist, that is a Ruska one, which is awarded the Nobel Prize in 1986 for this inventions. The first commercial TEM in 1939, and that is the 1 nanometer resolutions of this TEM. So typical volt for this one is 100 to 400 kilovolts. So this instrument is needed. So that is very important things of about your TEM. Now the basic principles of your TEM. So this is the basic principle. The design of transmission electron microscope TEM is analogous to that of an optical microscope. Just like in a TEM, high energy that is greater than 100 kilovolt, that much of electrons energy is needed. Electrons are used instead of the photons, and electromagnetic lenses are instead of glass we are using. So electron beam passes and electron transferred samples, and the magnified the image in form using a set of lenses, and this is image is projected onto the fluorescent screen over here. So this is your primary electrons, and this is secondary electron detectors over here. This is your backscattered electron detectors, and this one is your specimen. This is your specimen. This is X-ray detectors, and this one is your your simply DF BF. This is a bright field, and this is the dark field of your detectors. This one, and here is the fluorescence or the screen is there. So this fluorescence screen is help to image out or the recognize your signals of your dark or the bright fluor. So this image is very important for this TEM. So this is the image is projected on the fluorescent screen over here, right? So whereas use of the visible lights limits the lateral resolutions in an optical microscope. म्हणजे जर फ्लोरोसेंट स्क्रीन यूज केली नाही, विजिबल लाईट यूज केला तर त्याला एक लिमिटेशन्स असणार आहे, अँड दे कॅनॉट बी gives the fruitful results. So therefore we are using the fluorescence screen. So this is much smaller, the wavelength of electrons allow for the resolutions of this 0.2 nanometer in a TEM. So that is the reason why the fluorescent screen are used. This is the simple schematic diagram of your TEM. Just like your the same, here is the electron gun, here is the condenser detectors, this is the one and second condenser detectors. So condenser lenses are over here, but here is the your thin sample. सेम मध्ये सॅम्पल तुमचं एकदम बॉटमला आपण ठेवलं होतं, टेम मध्ये सॅम्पल तुमचं इथे सेंटरला आपण ठेवतोय. So this is the difference between SEM and TEM. This objective lenses, this objective of after the interactions of your samples, and then the ejections electrons that is can be objected, and then projector lenses over here, and this here the fluorescent skin. So this fluorescent skin it gives the images of your sample. Okay, so from this electrons beams are bombarding on your samples, and this is the all the backscattered electrons and this X-ray emission detections on these backscatter electrons over here, and that's backscatter electrons, the secondary electrons we can projected and we can amplified on the fluorescent screen. So this is a simple schematic diagrams of your SEM. Here is the difference, only the screen over here, fluorescent screen, and the sample is placed on the center, at the center, but in SEM the sample is placed at the bottom. So this is the difference, SEM and TEM. Now the instrument components of your TEM. TEMचे electronics instruments कसं तुमचं असणार आहे? The condenser system, that is the lenses and apertures over here. This is condenser and apertures. Objective lenses are there, and that's controlling the these your samples or the specimens or your this one. Objective lenses system, that is image forming lenses, and it is limitations, resolutions, apertures, and which is control the images conditions. Projector lenses are there. Here is the projector lenses, which is magnifying your images or diffractions patterns on a final screen. Then intermediate lenses, that is a transmitting or the magnifying the energy or the enlarge the images of your samples or the detectors. जे काही डिटेक्ट केलेले जे इमेजेस असतील ते आपण एनलार्ज करू शकतो विथ द हेल्प ऑफ दिस वन. So this is a simple component which is present in a condenser aperture, objective aperture, and selected area, that is the projector lenses and the intermediate lenses. So these are the lenses we are using over here. I think yes. बाकीचं आपण constructions continue in the next lectures. Okay, so now I am going to stop the class. Okay, इथे आपण थांबूया कारण विद्यार्थी संख्या पण फारच कमी आहे. So here we can stop the construction and working of your TEM. We continue in the next lectures. Okay.